Let's talk about buffers. Yay! All right, what is a buffer? What is a buffer? So, a buffer is a solution that contains a weak acid and its conjugate base, or a weak base and its conjugate acid. And what is magical about a buffer is it provides resistance to pH changes, right? Because it's able to neutralize the strong acid or strong base when it's added. So this is why when we are working with the pH meter, right, we calibrate the meter using buffers at specific pHs because they are resilient, right? They're resistant or resilient to pH changes. So we can be confident that the pH that the buffer is made at is its true pH, right? And it won't change much. So we can use it to calibrate our pH meter. So an example of a buffer is if we make a solution of acetic acid and sodium acetate, right? Acetic acid is a weak acid and its conjugate base is acetate. The sodium is a spectator ion, so what we will have is this hydrolysis reaction with acetic acid in water, right? So we form equilibrium between acetic acid and its weak conjugate base acetate. So both the acetic acid and the sodium acetate are going to dissociate or ionize in the water. So if we look at the resiliency, right? If we can basically add a strong acid or a strong base and see what the impact of these additions will have on the buffer. So if we add a strong base, if we add a strong base that's going to release hydroxide ions, right? They will be neutralized, right? They'll neutralize the hydronium ions. And what that basically means is it will convert these hydronium ions. It will basically decrease the concentration of hydronium ions. And as a result, the equilibrium is going to shift right to make more hydronium ions. So we will see a slight increase in pH, which we would expect because we've added a strong base, but essentially that equilibrium will be restored. So it'll be a slight increase, but not significant, generally speaking. And I'm going to come to when that's not the case. Now, if we add a strong acid, which will release hydronium ions into the solution, we're thereby going to increase the hydronium ion solution, right, in our buffer reaction. And so this is going to shift the equilibrium to the left, right, to the left, making more acetic acid. So we'll have a slight decrease in pH, a slight decrease in pH. So when we're looking at the resiliency of our buffer, the term that we actually use is buffer capacity, right? And this is the capacity of the buffer to maintain a steady pH, right? This isn't unlimited, right? So there are cases or there's certain concentration of, let's say, a strong acid or strong base that we add where we'll see a slight change in pH, but for the most part, it'll be steady. However, we may reach a point where that buffer capacity essentially breaks. And you can kind of think about this as if you think about you as a buffer, right? If you're like me, right, when you first wake up at the beginning of the day, especially if you have time alone and you're a true introvert and you're restored and rejuvenated in solitude, right? So you do all of your morning routine that zens you out. I like to have a cup of tea. I might do some writing, right? But I'm just with self and I am pouring into myself to essentially ground me, keep me at homeostasis, have a nice equilibrium, right? A buffer that is essentially resilient. So then you go out into the world, you go out into communities, and some of these communities or people that you come into contact with might have the effect of a strong acid or a strong base, right? And if I think about myself in terms of my buffer capacity, I may come in contact with someone that's really acidic, like a jerk on the highway that cuts me off. Any of you have road rage? I It varies. Most days I don't have road rage, but it depends on the day. But if my buffer is right, if I'm at a steady state, I'm at homeostasis, right? Someone cutting me off won't really change my pH much, right? I'll be chill, right? But then let's just say that four people cut me off, or there's like these series of events that maybe someone cut me off, then there's an accident, then there's a train, and now I'm looking and I'm like, oh crap, I'm not going to get to campus until like 3 minutes before class starts. So now I'm a little anxious, right? Because all of these things external are happening that is sort of impacting, right? Making me more anxious. I'm not as grounded as I was when I first left. So at some point, right, my buffer capacity might decrease just depending on the external factors. So that's just like a little metaphor to think about. If you think about yourself as a buffer, what do you need to pour into your buffer each day as you go out in the world in community with people that will be like strong acids and strong bases, and you'll also encounter people that are like weak acids and weak bases. So the buffer capacity is basically the way we can measure or quantify the buffer solution's ability to maintain a steady pH, right? The smaller the change in the pH when we add a strong acid or bases, that means that the buffer has a larger capacity, right? If we see a big jump in pH when we add a strong acid or strong base, that means that our buffer has a low capacity, right? Or I like to think of it as our buffer has reached its breaking point. So look at these two examples, right? Let's say both of these have the same volume. I have 1 liter solution of acetic acid and sodium acetate, both are at a 1 molar concentration versus one at a 0.10 molar concentration. Which one do you think will have a higher buffer capacity? So pause this video, think about it, intuit it. What's the first thing that comes to mind? So if you guess the one on the left, you are right. Even though, right, so basically the pH for both of these are the same, right? The pH of the buffers are the same. However, the first solution has a higher buffer capacity simply because it has a higher concentration of acetic acid and acetate. So essentially, we'd have to add more strong acid or strong base to like push its buffer capacity to its breaking point. So a buffer with a higher concentration is going to have a higher capacity. So going back to my metaphor, if you think about you as a buffer, right? Some days your buffer concentration might be like 0.002, right? How do you have a robust or high concentration buffer? Because you know that the higher the concentration of your buffer, the higher its capacity. Something to think about.